Okay, ladies and gents, we're going to talk about graphs today. We're going to analyze graphs. It means we're going to look at them and answer some questions about them. But let's do a little bit of a review so we can remember what all these words mean and how to find these things. So if I talk to you guys about the domain of a function, what values am I talking about? X values, good, okay? When you need to give me the domain, it's the X values. How do we find range? What are those values? The Y values, okay, good. That's a good start. When we talk about domain, how do we read a graph? Left to right. How do you read a book? Left to right. So left to right is how we read for domain, always. Negative infinities on the left, positive infinities on the right. How do you read range? Up and down? Which way though? It's low to high. Another way you can think about it is from the bottom to the top. We always start at the lowest to the highest. Always, always, always. All right, so let's talk about some notations about things. What do you guys notice about these dots? What's the difference between this dot and this dot? What does it look like? One's open, one's closed. Very good. Does anybody remember what an open dot means versus a closed dot? One's greater than or equal to, one's just greater than, right? Or less than or equal to. If you have a closed dot, that means this value is included. If you have an open dot, the value that point lies is not included. That's the or equal to, and it's closed. And then when we talk about notation, because we're going to use interval notation for everything now. So when we say it's from 3 to 7 or something like that, if it's a closed dot, you use brackets. If it's an open dot, you use parentheses. A bracket indicates that the number that is on that the bracketed number is included. A parenthesis, the bracketed number is not included. Questions? All right, another thing. What does this mean? All real numbers, good. It's another way to say all real numbers, but we're not going to say all real anymore. We're just going to say negative infinity, positive infinity. What goes on the ends of our infinities? Parentheses. Always. Always, always, always parentheses on your infinities. Why? Where does it, what's the last number? Or the first number? Is there a specific starting or stopping point for our infinities? No. So you can't say that, okay, this is where it stops and it includes the last number. There is no last number. So anytime you guys have infinity or negative infinity in your domain, range, your interval of increase, decrease, or constant, it's always a parenthesis. On your quiz, guys, it's going to be really important that your notation is correct. On WebAssign, it's really important that your notation is correct. If you have an open dot, you need a parenthesis on that number. If it's a closed dot, that means it's included. You need a bracket. So make sure you guys are paying attention to that. All right, another thing that we need to remind ourselves, what is this? F of x, good, that's how you read it. This is called function notation. F of x is a fancy way of saying what letter? Y, okay? From now on, guys, you aren't going to see y equals. It's going to say f of x. It's just a fancy way of saying y. There's no reason to be like, I don't know what that means. Yes, you do. F of x just means y. That's it. So if you had like f of x equals x squared plus 9. What is f of x a fancy way of saying? Y. So it's just, all that says is y equals x squared plus 9. All right, so let's go back to our question here. Looking at this graph, the thing that we like about a graph like this is there are specific starting and stopping points, right? If I had arrows at the end, it means it goes on forever and ever and ever and ever. So if you are asked to find the domain and the range for this, all right, when I do your answer keys for your quiz, I've already done them. My answer key on Notability looks like Valentina and Reagan drew all over it. It is virtually impossible to just look at all of this stuff and be able to find the increase, the decrease, all that by just looking. It is going to be very helpful for you guys to draw all over things. So get in the habit of doing it. But your domain, remember, domain is from where to where? Left to right or bottom to top? Left to right. So what is the furthest left that this graph has an x value? And what's the furthest right that this graph has an x value? -1 to where? 4. Okay, what's going on the ends? I agree there's a bracket on one of them. There's a bracket here on -1 and a parenthesis on 4. Why is there a difference? What about the dot? One's closed and one's open. -1 is including, the dot is closed, so it includes -1 in the value. On the right-hand side, 4 is open, so it does not include 4. But if you guys put brackets on both sides, that's not correct. You have to make sure your notation is correct. So you have to have your numbers right, and you have to have your notation correct. So pay attention to that. When we talk about range, it's the lowest point to the highest point. So what is the lowest value that this graph touches? -5, good. And it goes all the way up to what? To +4. What goes on each side? Why? Perfect, both included. All right, does anybody have any questions? So if you have a question that says, what is f of -1 and what is f of 2? Some of you guys are like, I don't know. Yes, you do. Remember, this is function notation, f of x. So they're telling you, okay, look at this function at the specific x value that they just gave you, and f of x equals what letter? Y. So what this says is, if you go on the x-axis to -1, what is the y value at that point? So if I go over here to -1, what's the y value? Yep, that's it. So now you go to 2. Go over to 2. My thing will catch up here in a second. Go over to 2. Draw an arrow up at where x is 2. What is your y value? Perfect. When they ask you f of a number, all they're saying is they're telling you where on the x-axis to look for the y value that is there to satisfy it. That's all that's saying. All right, we okay? All right, we're going to do these two examples together. We're going to talk about everything on these two examples. Just looking, what is the difference between 7 and 9? What does 7 have that 9 doesn't? Arrows. What do those arrows mean? Goes on forever and ever and ever and ever and ever. All right, so these questions can be a little more difficult. When you have arrows, then you're going to start talking about the infinities and all that stuff. You have to remember which axis you're looking at and what the arrows actually mean. So if I'm going to talk about the domain, remind me again how we read domain. From where to where? Left to right. So over here, do you guys agree with me, the negative infinity? Over here is positive infinity. Those arrows mean that this continues to get wider and wider and wider on the left-hand side, and it continues to get wider and wider and wider on the right-hand side. So what is the domain for this function? What x values occur on this negative parabola? Say it again. Negative infinity all the way to positive infinity, because it's continually getting wider. It's not, yes, I agree, guys. Both of the arrows are going to negative infinity on the y-axis, but that's not what we're looking at. We're looking at how wide this graph gets. So from the left-hand side to the right-hand side, it just continually gets wider and wider and wider. So if we look at the range, how do we read range? Bottom to top. So negative infinity's down here, positive infinity's up here. So my graph starts way down here, and it goes up, 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 till what? Till 1. Does it get any higher on the y-axis than 1? So how would I write that it starts way down at the bottom and goes to 1? Negative infinity, comma, oops. Negative infinity, comma, 1. What goes on 1? Y. You're right, Xavier, why? Because it's included. Somebody said, well, I don't see a big dot. You don't have to see a big dot. Do you guys see the graph right there? That means it's included. If it was not included, it'd be like a big open circle and the middle of it would be open, but that's not the case. So the graph exists there. So now it says find f of 0. Well, remind me again what that means, f of 0. That means I go to 0 on the x-axis and I tell myself what the y value is. What is it? Perfect. Now, we will practice more of these tomorrow. And you may not get it again, because I know you guys saw this before, but this still might be something difficult. This will always come back, our infinities and negative infinities and looking at domain and range and stuff. Why is 9 easier? Because it's got endpoints. You can see specifically where it stops, where it starts. So if I'm going to talk about domain, what's the furthest left the value is, and what's the furthest right? -4 to 4. Parentheses or brackets or what? Both bracket. Why? Because both the dots are close. Good. What's the range? What's the lowest? 0, right? Look. Go 0 to what's the highest? Perfect. What goes on both? Perfect. And then what is f of 0? Where 0 is on the x-axis, what is your y value? 4. Good. On your quiz, you're going to have one graph. I'm going to give you a graph. I'm going to say, what's the domain and range? That's how I want it answered. Then we're going to talk about the intervals of increase, decrease, and constant, which we're going to talk about in a second. Is everybody okay right now? Alrighty. Now, this part right here will not be on your quiz. We have moved algebraically finding domain and range to a later section, but I just want to go show you guys something. In order for you to find the domain of a function, there's 3 restrictions. Like if I had f of x equals 3x squared plus 7x minus 1. Do you have any restrictions? Are there any numbers that you could plug in here that would make the equation not exist? No. I can plug in any negative number for x and get an answer for y. I can plug in 0, and I can plug in a positive number. So your domain for a function like this would be negative infinity to positive infinity. Where you have domain restrictions is when square roots are involved, or if you have variables in a denominator. Because what happens when a denominator becomes 0? It's undefined, right? And then what happens if you're trying to find a real answer and you have a negative underneath the square root? What's the square root of -4? It's imaginary. It'd be 2i, right? So in this case here, what you guys need to, and again, this is not on your quiz, but we're going to talk about this. What would your domain restriction be? What number can you start with? Can you start with 0? What's 0 minus 4? -4. Square root of -4 is going to give you a 0. Okay, so you can't use 0. Can you use any negative numbers? No. What's the first number that you can start with to get a real answer? 5 would work. Anything smaller?
2.
What's 2 minus 4? -2. Still won't work. What else?
4.
Will 4 work? What's 4 minus 4? 4 minus 4 is 0. What's the square root of 0? So that works, yeah? So your domain here for this one would be 4 to infinity. Can we include 4 here? Yes, because you can take the square root of 0. Again, we'll talk about this later, but this is finding domain and range instead of given a graph and you guys seeing the points on a graph, you're actually finding it algebraically, but we'll work on that a little bit later. So, all right, we're going to take it back to middle school for a second here. Anybody remember the vertical line test or the pencil test? If you're given a picture of a graph, you can tell if it's a function or not by drawing a vertical line. If you draw a vertical line through the graph and it only touches at one point, anywhere on the graph, you can draw 15 vertical lines. If it only touches one time, then yes, this is a function. If you draw a vertical line and it crosses more than once, you guys see how it hits more than once? This is not a function. So what does this mean algebraically? All right, you guys can look at this. Let's call this A. Let's call this B. Is A a function? Draw a vertical line. How many times does it touch? Once, so yes. Is b a function? No, because it touches twice, right? But what does that mean algebraically? Well, think about this. Say this point right here was 3, -1, and this point here was 3, 2. What do you notice about those 2 points? They have the same x, okay? If you have a function, you cannot have repeated x values. So graphically, what happens when you draw a vertical line and it crosses more than once, that means you have more than one x value that is the same. So if you were given a list of points and they said, is this a function or not? You don't have to graph it and draw it. You could just look at the x's. If the x's are all different, then you're good to go. If there's any repeats in the x, it's not a function. Y can repeat every single time, but it's the x's that matter. Yeah? Okay. Scooting along. We're doing good. All right, we're going to talk about intervals of increase, decrease. Let's read this box here. A function f is increasing on an interval when, for any x sub 1 and x sub 2 in the interval, x sub 1 is less than x sub 2 implies that f of x sub 1 is less than f of x sub 2. Does that make sense? No. Okay. So now we're going to put it in high school math terms. Okay? That's just there to humor us for some of us. First of all, everything I write down here is really important, so write it down with me. I want you guys to write down increase, decrease, and constant. We're talking about intervals of increase, decrease, and constant. What does the word increase mean to do? It goes up. Perfect. What does the word decrease mean? It goes down. And what does constant mean? Perfect. Good job, guys. Now, if I look at this, and we're going to talk about this graph more in a second, and I said to you guys, where is it decreasing? What would you tell me? Okay, left side for what numbers? Okay, -2 to 0. Some of you would tell me it's from 4 to 1, which is true. It is decreasing from 4 to 1. But what is very, very important and can be very confusing sometimes is I want you guys to understand we read intervals of increase, decrease, and constant on the x-axis only. And the reason why, we are not concerned with how much the function is increasing or how much it's decreasing. We're concerned about the intervals over which it's happening, which means you only look at the x-axis. Another thing that is super important, when you are writing the notation for intervals of increase, decrease, and constant, it's parentheses only. Domain and range, brackets and parentheses. Increase, decrease, constant, parentheses only. The reason why, okay, these are called like little turning points here. Do you guys see here? The graph goes from decreasing to constant, and then here it goes from constant to increasing. You cannot physically decrease and be constant at the exact same time. You cannot physically be constant and then increase at the exact same time. So a bracket would indicate that those two things are happening simultaneously, which can't physically happen. So that's why you use parentheses only. Some of you are like, I don't care. Why? Just, I'll always remember that, which is fine. Just explaining why. All right, so here's my little tips. All right, again, we're going to make mistakes. We're going to say, okay, it's going down from 4 to 1. It's staying the same at 1, and then it goes up from 1 to 4, which I agree that is happening. That function is doing that on the y-axis. But I want to know the interval over which it's happening. So the first thing I do, and I'm telling you, my answer keys are all marked up. I take the x, I look at the x, I cross off the y. I want nothing to do with the y-axis. Cross it off so you don't even see the numbers. Now you're not going to be confused with, wait, is it the 1 to 4? You're looking left to right. We're going to read this, left to right. I will have spaces on your quiz that says increase, decrease, constant. You have to write it out. It'll be like this, increase, decrease, and constant. I like to start my graph from left to right and write it out that way. If you want to first find the increase, then the decrease, whatever, it's up to you. But I like to start over here. So we're going to start on the left-hand side, okay? This is what your PDF should look like when you turn the homework in. I start here at this point, and I follow the line. What is my graph doing? What action is happening? Is it going up? Is it going down? Is it staying the same? It's going down. So that's your interval of decrease. So on the x-axis, from what point to what point is your graph going down? Left to right, left to right, left to right. It's decreasing from -2 to 0. Perfect. So now I'm going to say, okay, I'm going to keep moving. What's happening from here to here in the green? It's staying the same. So from where on the x-axis to where on the x-axis is it staying the same? Perfect. And then what's happening from 2 to 4? It's increasing from 2 to 4. Now, this made it a lot easier that they wrote the words decreasing, constant, and increasing for you. Your answers change when you have arrows at the end. It makes it a little more difficult. But we're going to practice this. We're going to practice today. We're going to practice tomorrow. All right, we good? All right, let's look here. I don't really like the picture on A, so we're going to focus right here on B and C. Let's put arrows. On your web assign, you assume that there's arrows. It just kind of cuts the graph off, kind of like this. Just assume there's arrows here, and then we're going to assume right here that there's points. What is the domain and range for graph B? Everybody should be able to tell me right now. What do the arrows mean? They go on forever and ever and ever in both directions, right? So your graph is going to forever get wider and forever get taller. So what's your domain? Negative infinity to positive infinity. What's your range? Negative infinity to positive infinity. Okay, good. So now I'm going to talk about increase, decrease, and constant. And again, I know this is confusing. I get it. We're going to practice more. But before you guys even try to start looking at all this, let's make things a little easier on yourself. What do you notice that this graph does not have? A constant. So answer that. None. You have to say something. None, nope, nada, doesn't exist, whatever. But don't leave it blank. If there isn't an increase, if there isn't a constant, write the word none or no. So I know that you understand there isn't one. If you don't write anything, I'm going to assume you don't know what to do, so it's going to be wrong. Again, what's another thing that I think is really, really helpful to do since we're talking about intervals of increase, decrease, and constant? What should we cross off? Anything that has to do with the y. So I'm going to cross this off, and I'm also going to cross off the y's here. I'm not trying to confuse myself. I'm just looking from the left-hand side to the right-hand side. So think about it. This graph is coming from the abyss down here. So if we're looking left to right, this is negative infinity, this is positive infinity. I put my finger on the graph, and it's doing what? It's going up. What do we call that? Increasing. It's increasing from where on the x-axis? Negative infinity. To where on the x-axis? -1. Very good. So then what happens? I'm following the graph. Just put my pencil and I'm following my graph. What is it doing there? It's decreasing from where on the x-axis to where on the x-axis? From -1 to 1. Good. Keep following the action of the graph. What's happening? It's increasing. Is that okay to have two intervals of increase? Sure. It's going to increase again from where to where? 1 to positive infinity. Now, again, guys, I understand it's going up here and you're thinking positive infinity, but it's actually because it's on the x-axis, it's getting wider. What does this mean? Anybody? That's a U for union. right? It's like saying from here and here. If you write the word and, I'm fine with that. If you write a U, I'm fine. I think WebAssign, you have to write the U. It just means union. Now, going to this graph, this one's much easier. Why is this much easier? Say it again. No. Never, never, never brackets on increase, decrease, constant. Why is C easier? Because it has endpoints. You can say, okay, it starts here, it stops here. What do we notice about this graph? It's got it all. It's got increase, it's got decrease, it's got constant. Good. Kind of look at stuff before you. Now, what should I cross off so I don't get confused? Anything to do with a Y. I don't want to look at it. This is -1 here. This is 1. This is 2. This is 3. So left to right. Left to right. What is the graph doing from here to here? How do I write it? From where on the x-axis to where on the x-axis? From -2 to what? Perfect. Then what's it do? It stays the same. It's constant from where to where on the x-axis? 0 to 2. And then what does it do? It decreases from where to where? 2 to 4. So, all right, say you're having issues with WebAssign and you put a small u and it marked it wrong because it wanted a capital U, whatever. The first few assignments, I will be lenient. I'm telling you guys that. But you better turn in a PDF that shows this supporting work. All right, that shows me that you're putting in the effort. You know, we're still getting to know WebAssign, that sort of a thing. But if you turn it in and it looks like this, you're getting no credit for it. All right, it's only for the first few. Sure, only for the first few. All right, now I do want to bring one thing to your attention. Hang on. Okay, look if you have a question like this. All right, this new number 9 thing. What do you notice about this problem? It's got a gap. Good. All right, you're going to have questions, guys. There's going to be one on, like the first one on WebAssign, there's a gap. And you're like, wait, what does this mean? This means there might be a way, or there might be a time when the domain does not exist in a specific spot. So if I look at this and I asked you guys to tell me what the domain was. Remember, domain is left to right, yeah? So domain, what does this start at? -4, good. And it goes over to what? -2. What are the notations on the end? Brackets, good. Then there's a space. This is where the unions come in. There is absolutely no x values that exist on this graph right here. Everybody agree with that? Where does it pick back up? 0 to what? 4, okay? It includes 4, correct? Does it include 0? The way that I wrote it? No. And then you'd have a union. All right, there can be gaps in your domain. There can be gaps in your range. That's okay. But you have to make sure you account for it. What would happen, again, I'm going to draw this as best I can. There's one like this on your WebAssign. So this is one, right? Do I have any gaps in this lovely picture that I just drew? What do you notice about the 2 dots? Where are they? They're right on top of each other, right? There is not a gap. This is included here, but it's not included here. So there is absolutely no space on this graph where x values are not accounted for. Those two just happen to be on top of each other. If you have something right on top of each other, that does not mean there's a gap. But if you can visibly see a gap, if you can draw in the middle of it, then yes, there is a gap. Again, when you pull up your WebAssign, you'll see. We'll work on these a little bit more tomorrow. Last thing I want to talk to you about, and this is just on your graphing calculator when we get to it. What does the word maximum mean? If you have a maximum value, what does that mean? It's the greatest, the highest, all right? What's the minimum value? What's the minimum value? Lowest, right? So if you have a graph that has a bunch of these peaks and valleys, I'll go back to it in a second. If it has all these peaks and valleys, the peaks would be called the relative maxima, and the valleys are the relative minima. You can have more than one in a graph. It's just the peaks are the relative maxes, and the valleys are the relative minimums. You can have a bunch of them. That's just all that's saying. And same thing here, you're determining the relative minimums and maximums. But on a graphing calculator, we're not doing that right now. We're going to do graphing calculator stuff more around Thanksgiving-ish. So tomorrow, we are going to do something called piecewise graphs. Hopefully you guys saw them in Algebra 2. If you didn't, no big deal. We're going to go over them. It's not as difficult as you guys might think. All it is, we're going to take each little thing, maybe 2 lines and a parabola. We're going to graph all 3 of them, but you only want pieces of them. You don't want the whole thing. That'll take me about 10, 15 minutes tomorrow. We'll do that, and then I'll go over some quiz prep. Yep. Oh, peaks and valleys. Peaks, like a mountain peak. Just like the tops of the hills. All right, what I want you